With System SI, you can generate an HTML-based report file that will accumulate all the necessary simulation information into one easy-to-read report format, including simulation settings and tabularized worst-case min-max timings. However, with the new TimingDesigner interface, you can translate the results into the TimingDesigner environment for easy location of all critical measurements in an engineering-friendly timing diagram. In order to do this, we must first enable the interface. From the Tools menu, select Options, Edit Options, and then select Generate Report from the Measurement Report section. Then select the checkbox for Interface to TimingDesigner. This will allow access to enable the TimingDesigner interface. To translate the information into TimingDesigner, simply right-select on the simulation of interest, then select Generate Report. From here, you can select the TimingDesigner tab at the bottom, enter the path to the TimingDesigner executable file, and select Launch. TimingDesigner will begin to run, prompt you for some settings. Generally, just leave the default settings. Select OK. It will then generate a project file. Here we can just name this. I'm going to call it My Project. Select OK. Then it will generate the timing diagrams of interest. Here we selected on the right timing diagrams for both Memory 1 and Memory 2. We want both of them to be displayed. And then we select OK. TimingDesigner responds by opening up the diagram windows of interest. You can see the Memory 1 and Memory 2 diagram windows here for the write operation. If we zoom full, we can see that the diagram was created with the correct data pattern, the same thing that we had in System SI. And we can also see the locations of the critical measurements for worst case min and max timing values. Here we want to make our precision for settings boosted up to about 5 places so that we can see the decimal points go out to about 5 places here. So if we want to compare our measurements that are reported in TimingDesigner to our actual measurement report file in System SI, we can simply take a look at that report file. We've already generated that as report 4, so we can jump over to that report, scroll down to where the tabularized measurement data is, and take a look at a TDSH value. So TDSH, this is the memory measurement we were looking at. It's reporting a 3212.06 picoseconds for a minimum TDSH measurement, and that indeed coincides with the actual 3.21206. So those two measurements do indeed line up. So we can see that we're meeting our measurement event values, matching exactly what's being reported in the System SI report file. Just a little bit about what you're seeing here. Basically what is coming in is the clock signal, the strobe signal. All of these signals were selected so that they were enabled. When TimingDesigner generated the diagram files, it noted all of the worst case measurements and where they were located, what they were, whether they were set up or hold, and then placed them in the diagram file itself. Also in the diagram files are the appropriate headers to label what the diagram is displaying. Here is write data for bus group My Data Bus. It's rank 1. Sim corner was set to typical. This is receiver memory 2, and the project is noted here and the simulation case. Down at the bottom is just the raw location on your system of where the actual curve files were read from. If we take a look at the parameter spreadsheet, this is the spreadsheet associated with all of the event listings in the diagram. We can see that everything was located within a nice selected group. You can expand those groups to see the various values that were placed in the diagram. So you have derating variables. These are from your derating curves. All of the adjusted values from the derating curves were put in a variable and located in the parameter spreadsheet group here. Raw measures, these were all of the actual raw measurements taken without derating values into account, and so those are listed here under raw measures. And then the actual constraints take the adjusted values that were located in the variables, and then place them along with setup and hold requirements for that. And they're labeled appropriately. So TDH is a data hold, TDS is a data setup, and you can see the formula as they were set up here to include the actual requirement for the device as well as the adjusted value from the simulation report. If we look at the project manager is an accumulation of all of the files in this particular system project. So here, TimingDesigner will look for all of the timing diagrams that are present in this particular System SI project, and will organize them as such in the history folder as well as the results folder. So there's the history folder, here's the results folder, this is what we just ran. You'll see the memory information located here, and any of the accumulated history diagrams are run in here as well. So as you can see, the project manager for this project contains several diagrams that had previously been run. With this specific project, I took the liberty of renaming the project folders to be more reflective of the System SI simulation results they contain. If I browse my simulation history within System SI, I get the same organization for the results as you see in TimingDesigner. This makes it convenient if you'd like to look at previous simulation runs for a project in TimingDesigner. You can quickly find the specific run of interest. Translating previous simulation data into TimingDesigner is exactly the same as described with the current simulation. Simply open the results browser, display the diagrams of interest, then with the right mouse button, select the Generate Report option, and proceed as previously described to generate all timing diagrams for the selected simulation runs. All diagrams previously generated will be included in the resulting Project Manager window.